Welcome to Spring LIB.
Now the question is, explain each statement in detail using resonance structures. First is, a phenyl group C6H5 is an orthoparadirector that activates a benzene ring towards electrophilic attack. So first we are taking this statement. Phenyl group is electron releasing group. So if the benzene ring is present here and phenyl is here, then it is releasing electrons, and by that it is increasing electron density in the second ring and making it more active towards electrophilic attack. So it will be electron rich, particularly at ortho and para position. So that is how it is activating the benzene ring. And orthopara attack we can explain on the basis of resonance structures also. So here it is given that when ortho attack is taking place, the resonating structures of the intermediate are this. And out of this, this one, fourth structure, third structure, resonating structure is stabilizes this positive charge at the carbon, which is directly attached to C6H5, is stabilized by C6H5, and that is why this intermediate is quite stable, and we are getting the preferred structure, that is ortho compound. In case of meta, resonating structures are there, but no resonating structure is stable. We are looking for the positive charge in the structure where it is directly attached to C6H5. That structure is not here, and that is why this intermediate is not stable. And we are not getting the preferred structure by meta attack. Whereas in case of para, again we can see in the resonating structure this stable intermediate, positive charge at the carbon where C6H5 is present is stabilizing it, and by that the preferred compound para is formed. So by resonating structure also it is quite clear that a phenyl group is an ortho-para-director that activates the benzene ring towards electrophilic attack. In case of second statement, a nitroso group NO is an ortho-para-director that deactivates a benzene ring towards electrophilic attack. So first we will see that how it activates the benzene ring, and here you can see in the resonating structure these are the resonating structures. And out of that, this one is stable because of this carbon which is directly attached to an O group is having the positive charge and it is stabilized by that. And we can get the ortho and para compounds. Ortho and para should have the same effect and stable resulting intermediate is formed. That is why it is ortho-para director. So how the stability is taking place, that we can understand by this structure. In the intermediate compound, when the positive charge appears, nitrogen with double bond O, and if the positive charge is here, then electron pair which is present over this nitrogen can be given to stabilize it. And we can get the stable intermediate. This we can see in the orthoattack also, and that is how NO is an orthopara director, and we can get the orthopara electrophilic attack. The second part of the same statement is it deactivates a benzene ring towards electrophilic attack. By resonance, we can see that it is stable intermediate, but the second effect is inductive effect, which is working in opposite direction. That is due to more electronegative nitrogen and oxygen atoms as compared to carbon, and by that what happens? That same intermediate is deactivated or unstable because the inductive effect is working in opposite direction. So if the positive charge is here at this carbon, which is directly attached to nitrogen and oxygen, inductive effect is working also in opposite direction. So nitrogen and oxygen is more electronegative. It is taking the electron and by that it is destabilizing this intermediate. So because of this inductive effect, what happens? The benzene ring is deactivated towards electrophilic substitution. It is taking the electron from the benzene ring and decreasing the electron density in it. So towards electrophilic attack, it is deactivated.